I want to first thank Hyperion and reaching out to me and inviting me. We had a terrific talk earlier about the operating system level stack. I'm going to talk at the stack a little higher than that. I wanted to start with an overview of our center because you have to know a little bit about the sort of breadth of what who we serve in order to understand the complexity or the challenge in meeting their software needs. And then a few things that, there's actually a lot looking forward. I just have a few things that are shorter term where we know kind of more precisely where we're going. So we've been around for 30 years. We are a center that's primarily funded by the state of Ohio. We serve the universities in Ohio and also industry in Ohio. And that's been part of our mandate from the start, to serve research in Ohio across those sectors. And I'll include in that research hospitals. So, and then we're located at Ohio State University. They are the largest university in the state, and they're a very large portion of our user base. So this is some stats just from last year, so you get an idea. We have 26 universities using us right now. We have 41 companies. We've served over 1,000 users this year on 500 and some projects. And we also have classroom use. The scope of our core hours, I'm not going to dwell on too much. We deployed a new system late fall, so we hope we should have some bigger numbers next year. And then a little bit about our science. Chemistry, so I was very interested in the Institute talk earlier. Our founders came from that field. The bulk of our core hours are still in that field, but we serve many fields. And we've got growth, geosciences, biological sciences, and then there's the small ones that you don't see, but we get contacted from places where we don't expect. I had someone inquire with me from psychology asking if I had K&L, and it kind of blew me away. I'm like, really? We couldn't meet their needs at our center, but we helped them get on Stampede in that case. So the systems right now, we have 3 clusters in production. Our most recent deployed, as I mentioned, in the fall, is Owens. So a little overview of the systems. What does that mean from a software point of view? Well, these are all Intel architecture host processor, Intel Xeon, so that is helpful, but there are 3 different generations. We have 3 different generations of of GPUs across these systems as well. We have storage systems available across all these systems. And we have 3 generations of InfiniBand interconnect. So that's what we deploy across. And then just kind of an overview. We do the things that most HPC centers do. We have direct client support, deeper engagement. We partner on proposals. And we have some web software, which I'm going to talk about as well. So I wanted, when I was thinking about our software, I came up with this pyramid. And we're going to come back to this at the end of the talk, because this is very much a deployment perspective of our software. That we have our base software, which is our system software, and all the tools behind the scenes to manage those systems and the deployment of their software. We have the group I manage is the scientific applications group. We do the solvers, the libraries. We overlap with the systems group on compilers, MPI libraries. and a few things there. And then we have a web group. We have a web team that, and we'll talk a little bit about kind of their primary product right now that provides convenient interfaces to our system. So if I first talk about what we deploy, we have, to support all those fields of science, our cluster that's been kind of our main cluster for about 5 years has right now about 150 packages. Our new cluster deployed in October, I just looked, and we already have 100 different software packages on that system. And we have several versions of those packages. For the libraries, we may have 6 builds for a given version to support different compilers, different MPIs. So it's a very large, complex system to maintain. It's difficult to meet all the dependency requirements and have compatibility. We have our software ranges from simulation codes. They may come from ISVs. They may come from a community. They may be open source. They may not. We have languages like R and Python, which have built into them their own sets of packages where our users all have different ideas about which ones are needed and maybe which versions are needed. And then because we do buy software, so we buy software, both tools and simulations, codes in the engineering area and the chemistry area. And because we have a multi-institution client base, licensing is actually, can be a challenge for us. That the ISVs don't always, typically they don't have an off-the-shelf license that fits our use case. So, so we spend time there as well. An example just of some of the things we might do. So we support molecular dynamics. We have several codes there. They typically come in a CPU version and a GPU version and possibly a KNL version. And so we recently just deployed a bunch of new GPUs on our newest cluster and have been generating the codes there, looking at the performance of the codes so we can encourage our community to take advantage of those resources. Similarly, we've been deploying some tools in the machine learning, deep learning. We're getting high demand for those and uptake of using our GPU resources in that area. We also, like everyone, have a growing interest in data analytics. I think it was mentioned earlier that academic supercomputer centers, we're not seeing the same percentages of that use. I think it is growing a little more slowly, but we are seeing interest, and we have been deploying stacks to support that. And also we sometimes just have really large analysis from simulation, more traditional simulation, but from ensembles or suites of runs where we need to make sure that we have the right resources. Typically that's not software limited, but is memory limited. I wanted to talk about one of our arrangements with a vendor. We all are familiar with Matlab. MathWorks has agreements with many universities, so we get a lot of requests because our students all grow up with it and are very familiar with the tool. We've had a long history of deploying it through lots of iterations of agreements. We're really happy with our latest agreement. Our latest agreement, and we actually piggyback on Ohio State's license for general MATLAB support. We additionally buy licenses for the DCS for parallel execution. But our general license now is accessible to all of our academic users. So for many years, we had to tell people at the other 20 some odd universities, sorry, the only way you can use, run here is through our DCS licensing, and your own, need your own parallel license, you need your own licenses back home. About a year ago, we had an agreement where we could just point back to their home licenses and they could run, and we had all the toolkits. But that was problematic, actually, because most of our student users would come to us and they're like, well, I just run on my laptop. I got a special key. I don't have a floating license to point back to. Anyway, so MathWorks has come a long way in providing an environment where we can support our community being multi-institution. So that's one case, and every one of these ISV arrangements is its own case. Additionally, my group works and collaborates with researchers who develop their own codes. This is an example of one such collaboration that is funded by the National Science Foundation through their Polar programs. The Ian Howitt and MJ No are the science developers. They developed a code. Originally, it was a Matlab code to do digital elevation models. So they take stereo images and they compute elevations. And then they convert the code to C to get more performance. To C OpenMP code, we're working with them to add MPI parallelization and to just improve the robustness of the code. So my group kind of has these science capabilities and the tools for those developing their own science codes. The web and interface applications, their job is really accessibility of our resources. And their primary product is called OnDemand. So when new users come to our system, they can use the traditional method that we all love, which is to SSH. I actually don't use OnDemand. I'm quite happy with my terminal window, but recognize that many of our users find that a very foreign environment. They've grown up with GUIs. Their phones are more sophisticated than our environment. And so we're trying to bridge that a bit. So they can come to our system now, log in through a web portal, and they can transfer their files, they can launch jobs, they can manage their jobs, view status of the system, and get VDI windows, and even run some specific applications. So this environment actually came out of a few things. There was a prior on-demand effort just to provide the sort of the logging capabilities, the file transfer, the job support. And then there was a separate effort on our industrial programs to develop workflows and be able to launch some of the engineering apps that our commercial clients used. And they've been put together now under a single environment. This is some of the things that are provided, and I think so besides the fact that not having to log into a shell is a big help to our novice users, being able to we're now providing a development kit so people can put together workflows for applications, and so it can combine. It typically has worked well where there was sort of a very specific type of simulation problem, but people might want to run it with different parameters. Our very first effort at this was in the welding, supporting some welding problems. And from that has come a methodology for supporting that. a little example would be something like this beam example. So this can be used to support particular kinds of problems in an industry. It could be used to support classroom problems. And it could be generalized to support kind of a more flexible interface to some simulation codes. And so in this case, users can just input their parameters. Behind the scenes, the input files, those text input files that are ugly, but we all are familiar with in this industry, get created, job scripts get created and submitted to the system. When the results are available, then some outputs are provided back to the user. And this is another case. This was one done for one of our industry clients. We, for container testing of strengths of containers. If we, I'm helping with our time actually. I don't have a lot more. So we just deployed our GPUs, and we have other new technologies in our system that we would like to have our software take advantage of, either the software directly or the users through workflows. One of those is our new file system from DDN has burst buffer, and the IME device, and so we're getting ready to roll that out for users, and as part of that, my team is working on software support and looking at some of our codes or libraries and making sure that they're able to take advantage of it. On the web side, we've had a lot of interest in Jupyter. Oops, too far. In Jupyter, in RStudio, in using Matlab in a more convenient way on our system. So that's being integrated with our OnDemand environment. That's in beta right now with some users. As soon as we made that available, on the Jupyter side, we had a request for Julia, so we made sure that that was available along with it. So we continue to try to make access to our software easier for our clients. And one of my colleagues suggested I had a wrap-up slide. And in thinking about it, I realized that when I made this graphic, when I was looking back through my slides, that I had made it wrong. For my users, this is what they see, right? They want to see the web interface, the easy access. Some of them want to work at the level my group does. They deploy their own codes. They want to see the libraries. They want to use the performance tools or debuggers. And hopefully very few, but we do have some, because we have an MPI development group at Ohio State. Very few are going to really work and dabble at the lowest levels. And so when we think about our software, we really need to think of it from this user-centric view instead of our own kind of bottom-up view. What they need is an easy way to do their science. And they'd really like most of this hidden from them. So I thought I'd end on that.
Any questions?
So this open on demand is an interesting idea. If an application writer visualizes data through it or gives some output to its users through that interface, are they tied to it? What happens if then they take the code to a different supercomputing center?
So we've done a couple things. One thing is we have, when they access through this environment, they get to their home directories and their directories on our parallel file systems, right? So any output from their simulations is available and created in their home directory. They run as themselves. That was actually a key thing. And not there in some of the gateway environments. But it was very important. Our system administrators have been involved with this. So that was sort of a key thing from a security point of view, that we allow them to run it themselves. So they can take any of the files that come as output. We usually put behind these apps common tools. So the visualization tool might be ParaView, could be Visit. So we're still using the standard HPC technologies underneath.
So I was curious about how your interface is for writing these app kits, I guess is the name of it. Is what you're calling it for. Like when you make changes to applications or workflows or things like that, are you having to do some major development, or is it set up in a way that's simple to make changes and things like that?
I'm not in the web team, so I can't comment on all the complexities. I know we've been working towards making sure that they're using all of our standard software installed. So for example, if we're upgrading a version of a solver underneath, right, they may have to change a module load in a file to use a new version. We do make sure they're using modules, the module environment that we use, kind of the standard environment that we use, so that they can find their paths. And we actually had to work with the group because we had web developers who weren't HPC users initially in that group, and so they didn't realize that there were sort of tools to do some of these things under the hood. So we've been working better across that group to make sure that when we update stuff, they are aware, or we test to make sure it works in that environment as well as our standard, our comfortable environment of command line. So I wouldn't say we're 100% there where everything's seamless, but we're getting there.
Okay, and what influenced your decision to write something in-house versus going with some of the many products that are already out there trying to do something at least similar?
Well, we do use we do build on top of things that are out there. But mostly it came from, we were doing bits and pieces of this over many years, right? And so it was really trying to unify what we had into a single environment. But a few of the things that were specific was the need for the user to run on them as themselves, right? So that was a big one that had to have a solution that would work in our environment with the HPC system. But when we were looking at, so for example, the standard file upload app, there's some limitations for really large data transfer. So there we want to go integrate with Globus, for example, or something. I mean, we're trying to use sort of the best practices where it makes sense.